So for this part of the real numbers subtopic, we're going to be looking at ordinary and standard form. So looking at ordinary and standard form, you're required to put numbers in standard form and know how to do the mathematical operations in standard form. So mathematical operations in standard form are the four of general mathematical operations, which are addition, subtraction, multiplication, and division. And standard form involves putting a number to the form a times 10 to the power n, where n is a positive integer or a negative integer, where an integer is a whole number, and a is a number between 1 and 10. So, for example, if we have 5 times 10 to the power 3, or 6 times 10 to the power minus 7, where in this case n is 3 for the first standard form number, and a is 5, and in this case a is 6 and n is minus 7. So let's start with an example of how to, just a refresher on how to write numbers in standard form. So we have 650. So you have to make sure that there's only one digit, right, before the comma, right? For example, if you look at 5 times 10 to the power n, or let's say if I had written 4.7 times 10 to the power 3, right? You see how there's only one digit, which is the 4, before the comma. So make sure that there is only one digit before the comma, which means, yeah, to the left of the number. So on 650, we have 650. And now we have to place our comma. It starts here, and our comma now has to move until we have only one digit before the comma. So it's going to move 1 places, then 2 places, which is 6.5. And it has moved 2 places, so it's going to be times 10 to the power 2. So as a note, the decimal moved 2 places to the left. That's why n is equal to plus 2. It's positive 2 because we moved, 2 places to the left. Okay, then the next one we have 37,000. Again, writing it down, 37,000. Since we do not have an evident decimal, that means it comes after the last 0. And then now we move it and count how many times. So 1, 2, 3, 4. So it has moved 4 places to the left. So our 37,000 standard form will be 3.7 times 10 to the power 4. There we go. So unless if it's expressed that, leave it in 4 significant figures, or otherwise you just write as 3.7 times 10 to the power 4. You don't have to write 3.70000 times 10 to the power 4 unless if the significant figures are specified. The zeros after the comma are redundant in this case. So we have 5,000 again in standard form. So 5,000, comma 0, move our decimal 1, 2, 3 to the left again. So that's 5, comma 0, or just 5. Times 10 to the power 3. Then the next question, 708,000 standard form. So we have 708,000, comma 0, and then our comma again moves 1, 2, 3, 4, 5 places to the left. So it's going to be 7.08 times 10 to the power 5. Note that in this case, this 0 is significant because it's between two digits. So we can't just exclude it. So we have to write it like that. And then the next one, we have 76.25. So now the comma is already between certain number of digits, and it's going to move first a one digit before the comma. It's going to move only once. So then that translates to 7.625 times 10 to the power 1. It only moved once. And then we have 0.062. 0.0062 to standard form. So now our comma is, there's only a 0 before the comma. So to have the first digit, the first non-zero digit, that means that our comma has to move to the right. So if it's going to move to the right, that means it's going to have a negative power on the exponent. So it's going to move 1, 2, 3, because the first non-zero digit is a 6. So we end up with 6.2 times 10 to the negative 3. So as a note, the decimal moved 3 places to the right. Therefore, in the format a times 10 to the power n is going to be a negative 3. Right, so take note of that. And we have the same case for 0.526. Again, our decimal has to move 1 place to the right. So we're going to have 5.26 times 10 to the power minus 1. Right. And same for this one, we have 0.00309. Again, it's going to move 1, 2, 3, 3 decimals to the right. So it's going to be 3.09 times 10 to the power minus 3. So that's how you put numbers in standard form. So we now have a case, just for a refresher, between significant figures and standard form. So A asks us to put in standard form for the same number, 0.00658. So in standard form, the comma is going to move 1, 2, 3. Oops. 3 places to the right. So it's going to be 6.58 times 10 to the power minus 3. And then B, 0.00658 to 2 significant figures. All right, again, we have to put down as a reminder which ones are the 2 significant figures. So these zeros are not significant before the first digit. So the first significant digit is going to be 6, and the next one is going to be 5. So now we have to ask ourselves, what happens to the number next to the second significant figure? Is it greater than 5 or less than 5? 8 is greater than 5, so we round up. So then what we end up with is 0.0066. So that's how we put the same number in standard form and in significant figures, and you can actually get different solutions. So adding and subtracting numbers in standard form, there are 2 ways to do it, either you convert to normal form first, then add them, or you leave them in standard form but to the same base. So that means because in this case, let's look at the example that we have 6.28 times 10 to the power 3 plus 9.5 times 10 to the power 4. So when you look at it, we have the power 3 there and power 4 there, and you can't add things that are not of the same power. So let's look for option 1. So option 1 is changing from standard form to ordinary form first. So we have 6.28 times 10 to the power 3, right? So times 10 to the power 3, so we have 6.28 10 to the power 3, and then that means that to put it back to ordinary form, the comma has to move, because when we took it to standard form and it is a positive number, the comma moved to the right. Now to put it in ordinary form, the comma has to move to the left. Sorry, so it moves to the left. Now it has to move to the right, okay? Because this is a positive number. So it's going to move 3 places. So it's going to be 1, 2, and 3. So here there was a placeholder 0. So that means that that's going to be 6,280, right? And then 9.5 times 10 to the power 4. So that's 9.5000 times 10 to the power 4. Again, move it to the right this time to make it normal for ordinary form. 1, 2, 3, 4. Comma is going to go there. So then we're going to be left with 95,000. Okay, so now what we are adding is then 6,280 plus 95,000. And when you add that up in the calculator, you then get 101,280. And then the next step will be change back to standard form. So in standard form, we have 101,280. Again, the comma is now moving to the left. 1, 2, 3, 4, 5. And that's going to be 1.0128 times 10 to the power 5. So this is one of the methods where you first change from standard form to ordinary form, then do the computation, whether it's subtraction, addition, multiplication, or division, and then change it back to standard form after you found the answer. Or I think this is a shorter way. You can convert both numbers involved to similar bases, to similar powers in standard form. So in this case, we had 6.28 times 10 to the power 3 plus 9.5 times 10 to the power 4, right? So we have 3 and 4. So in this case, it's easier to convert the 4, the highest power, which is this one, 4, to 3. So what that translates to is 6.28 times 10 to the power 3 plus 9.5 times 10 times 10 to the power 3. Because what 10 to the power 4 means, it just means 10 times 10 times 10 times 10, right? So it means 10 being multiplied by itself 4 times. But now if you want to remove one of the 10s, we're left with 3 of the 10s, right? So that's what standard form is. So now we're left with both to the same power, in that we have 6.28 times 10 to the power 3 plus, so now you multiply 9.5 times the 10, right? We should end up with 95. So that's going to be 95 times 10 to the power 3. When you look at it, now you have times 10 to the power 3 and times 10 to the power 3. Once you have the same powers, you can now do computations like subtraction and addition. So this is for subtraction and addition. It's strictly by the same powers. All right. So now it's the same as saying, because now you can. Okay. So let me just write that. So subtraction and addition, you need to have the same power in standard form. Great. So now going back, we now have 6.28 plus 95 if you factor out 10 to the power 3, because that is common in both now. So when you add those, you get 101.28 times 10 to the power 3. But when you look at it, we had said for standard form, you need to have only one digit before the comma. So again, we have to change this to standard form. So this comma is right there. It moves 2 places, such that we are left with 1.0128 times 10 to the power 2 times 10 to the power 3. And in standard form, if you're going to multiply two numbers with a similar base, so the base in this case is 10, you add the powers. So if similar base numbers are multiplying add the powers. For example, if you have x to the power a times x to the power b, that's going to be x to the power a plus b. So when we look at it, here we have 10 to the power 2 times 10 to the power 3. That's going to be 1.0128 times 10 to the power 2 plus 3, that's 5. So you realize that these are equal. So you can choose which option you want to do. First, changing to ordinary form, then doing the calculation, or changing to standard form with the same bases and some powers, and then doing the computation, and then changing to standard form to make sure that you only have one digit before the comma for the final answer as well. Okay, so yeah, let's say we have this one, which is for subtraction, where we have 1.1 times 10 to the power minus 3 minus 8.7 times 10 to the power minus 4. Again, they are different in that we have minus 3 here and minus 4 there. So changing to ordinary form, firstly, so to ordinary form, we end up with 1.1 times 10 to the power minus 3 being equal to, so for 1.1 we realize that it's minus 3, and to get minus 3 we move the comma to the right. Now we have to move it to the left 3 places. So again, it's going to move 1 place, 2, 3, such that we are left with 0.0011. And then the next one was 8.7 times 10 to the power minus 4. Again, we just add some placeholder zeros. It moved 4 places to the left now. So 1, 2, 3, 4. So right there. So that's going to give us 0.000887. So then you subtract 0.0011 minus 0.00087, and you can either put this in abacus form. It's probably easier if it's a paper 1 question and you don't have a calculator. But obviously if it's paper 2, then it's okay to then use a calculator, because then it'll be like this, and then you have to subtract, and then you end up with 0.00023. Now we have to convert back to standard form. So we have the comma right there, and we have 2, 3. We have to move it 1, 2, 3, 4 places, and that gives us 2.3 times 10 to the power minus 4, because we're moving the comma to the right. Perfect. And if you want to do it the other way around, where you convert them both to the same base and the same power, so we start by convert both to same base and power. So we have 1.1 times 10 to the power minus 3 minus 8.7 times 10 to the power minus 4. And we're choosing to convert 1.1 times 10 to the power minus 3 to minus 4 because it's the bigger number in this case, because we know that if the power is more negative, it's the smaller number. So minus 4 is smaller than minus 3. So converting to minus 4, that means that we're going to add a 10, right? So that's going to be 1.1 times 10 times 10 to the power minus 4 minus 8.7 times 10 to the power minus 4. Because when you look at it, right, I said if they're going to be, so that's going to be 10 to the power 1. So like I said, when you look at it, 10 and 10 have the same base, and like I initially mentioned that if similar base numbers are multiplying, we add the powers. So in this case, if we add 1 to minus 4, we go back to minus 3. So just as a cross check to make sure that you're expanding minus 3 to minus 4 times 10, right? So 10 times 1.1, that's going to give us 11. So just expressing this bracket is going to be 11 times 10 to the power minus 4 minus 8.7 times 10 to the power minus 4. And when we look at it, we have minus 4 and minus 4. We now have similar bases. So now we can do the computation. Alrighty. So that's going to be 11 minus 8.7, which is easier to compute than for the decimal format, the longer format, times 10 to the power minus 4. And that's going to give us 2.3 times 10 to the power minus 4, which is what you had gotten with the other answer. So you will get the same answer, just choose the option that's easier to work with and that you're more comfortable with. Okay, so you can try the following exercise questions with subtraction and addition. And now dealing with multiplication and dividing numbers in serial form. So now you have to apply the laws of indices, since only the power changes for the same base. So if you're going to multiply, you don't really have to change to the same base. They're always going to be the same base, which is going to be 10. But now what happens is you then add the powers. So for example, we are given this format right here. 10 to the power a times 10 to the power b is going to 10 to the power a plus b. So just remember that. So for example, if we have x times 10 to the power a times y times 10 to the power b, x and y multiply as you normally would do multiplication, and then now the powers of the bases are going to then add. So that's the same rules for division as well. 10 to the power a divided by 10 to the power b, you subtract the powers, a minus b. So the power of the numerator minus the power of the denominator. Therefore, if you have x times 10 to the power a divided by y times 10 to the power b, you still do the computation of y, x divided by y, times 10 to the power a minus b. So, for example, we have 6 times 10 to the power 9 being multiplied by 8 times 10 to the power 2. So that means that it's going to be 6 times 8 is good, because the bases are the same. So 10 and 10, that's the same, times 10 to the power 9 plus 2, because it's multiplication. And then that's going to give you 48 times 10 to the power 11, because 9 plus 2 is 11. But now remember that this 48 is not in standard form, because we have two numbers, 2 digits before the comma. So the comma is going to move one place to the left, and that gives us 4.8 times 10, then times 10 to the power 11. And again, we now have 10 to the power 1 times 10 to the power 11 multiplying. So we add the powers, 4.8 times 10 to the power 12. That's the answer. And then when we are dividing, so we have 6 times 10 to the power 3 divided by 8 times 10 to the power minus 2. So again, laws of division still count. So 6 divided by 8 times 10 to the power 3 minus 2. Take note of the double negative in this case, because you're subtracting, but then you're dividing by a negative power, so it's going to be minus. 6 divided by 8, that's 0.75 times 10 to the power 3 minus 2, that's going to be plus 5, so to the power 5. But now when you look at this, right, 0.75 is not in the standard form, so to put it, you move the decimal to that side, to the right, such that you are left with 7.5 times 10 to the power minus 1, because you have moved the decimal place one place to the right times 10 to the power 5. And when you expand this, because now you have 10 to the power minus 1 and 10 to the power 5, you get 7.5. You're multiplying, so you add minus 1 plus 5, that's plus 4, 10 to the power 4. And that's how you get your answer. So for an exercise, can you evaluate the following, giving your answers in standard form? The first few are mostly on division, and then for number 2 is multiplication. So you can take a screenshot or write them down, whichever way you prefer, and then give them an attempt.